We now continue with the genes that describe the physical and logical design of the facilities in the network. These are facilities floor areas, zones, location sizes, aisles, aisle levels, travel nodes, and aisle faces to travel link. Floor area represents the distinct vertical floors in a facility, such as multiple floors or mezzanine floors that have an associated floor height. In our example, each facility in the network has only one floor. Facility zone groups storage locations logically for the purpose of controlling the flow of inventory through the facility. Facility zones are a logical subdivision of facility and can be used to control, among other things, the placement of SKUs in the facility during put-away. In our example, we use the standard zones predefined in OC. These are WHAA, associated with pick-faced and fast movers, WHBB, associated with intermediate and velocity class B movers, WHCC, associated with intermediate and velocity class C movers, WHDD, associated with bulk and slow movers, and WHXX, which are locations not racked. Location size is a composite concept used to define the available storage volume in storage locations and also the carry capacity of resources in the facility. A storage location is a physically identifiable area where inventory can be placed. All locations and resources must have a valid location size. Location length, width, and height defines the volume of a location size. OC assumes the length, width, and height to be from the perspective of someone facing the entry side of the location. Aisle face is a unique number in the facility that identifies adjacent groups of locations where inventory can be placed. Examples of these include a row of racked storage bays separated by an aisle. If a location is standing alone with no adjacent locations, it is still given a unique aisle face. Aisle face sequence is a unique number in the facility that allows you to indicate the logical proximity of aisle faces to each other. The logical proximity of two aisle faces is the absolute difference of the two aisle face sequences being compared. In our example, aisle face 20 is logically closer to aisle face 127 than it is to aisle face 131, as the absolute difference is greater. Bay sequence and paired aisle face refines the definition of logical proximity of locations in an aisle face or two aisle faces on either side of an aisle. OC uses the Bay sequence in conjunction with the aisle face sequence to determine the location sequence for individual locations. The absolute difference between the location sequences of two locations determine their logical proximity. Ascending and descending indicates the preferred travel directions for multiple tasks in the same aisle. For east-west aisles, ascending means travel from left to right, and descending means travel from right to left. For north-south aisles, ascending means travel from top to bottom, and descending means travel from bottom to top. If a zigzag pattern of task execution in the same aisle is required, then either ascending zigzag or descending zigzag must be used. In this case, the aisle face must be paired with the aisle face directly opposite. Aisle face logical orientation tells OC how an aisle face is oriented on the facility floor plan. This is a logical orientation, which means that you decide what is north. The direction points into the entry point of the location in the aisle face. The aisle face logical orientation also controls the slot pattern which is constructed for a bay. Aisle face starting x and y coordinate is the x and y coordinate of the starting location in an aisle face, where the 0, 0 coordinate is the top left-hand corner of the facility floor plan. The starting coordinate is the top left corner of the first location in the UL face. UL face storage types describe the storage characteristics of the UL face, such as entry, exit points, lane characteristics, and bay and slot pattern. UL face level is the physical level of the rack storage or shelving. Number of bays indicate the number of bays in the UL face. A bay is typically associated with space between the upright supports in racking or shelving. Number of slots in bay indicate how many slots there are in the bay. Slots are logical subdivisions of a bay and represent discrete storage locations. Location types indicate the functional processing capabilities of locations in the facility. It is the primary concept that influences the flow of material through the facility. Receiving is where receiving of inventory happens. Reserve storage is longer term or primary handling unit storage. Letdown storage is primarily for letdown to forward pick storage. Forward pick storage is short-term or unit storage where pick faces are established. Consolidation is where packing happens, shipping is where load building happens, and staging is where picked and packed shippable handling units are staged for loading. Trailer doors are the physical doors through which inventory arrive and leave. Facility travel nodes represent the intersections of the possible travel paths in the facility. Travel node X and Y coordinates are the X and Y coordinates of the facility travel nodes in the facility. Facility travel node 1 and node 2 indicate the links between the facility travel nodes. Travel direction indicate whether the link is directional. UL faces in travel link associates an UL face or UL faces with a link. You can see the travel paths in a facility by looking at the floor plan. Next, we discuss the facility's outbound packaging gene. Outbound packaging materials are the packing containers that will be available for use in the facility outbound process. Packing container identifies a packing container such as different sizes of cartons that may be used in the facility during the outbound process. Packing container length, width, and height define the dimensions of a packing container. The process decisions, carrier service selection, carrier service parameters, and standard times genes are used by OC to establish the operational rules that will control supply chain execution in the different network nodes. For most of the DNA concepts in the process decisions gene, there are predefined options and styles that implement specific behavior. You can refer to the user guide for details on the options and what they mean. Purchasing frequency determines how often, in clone run real time, the current inventory position of the SKUs in the node are evaluated and order quantities determined. Put away style controls how OC applies decision biases when determining a put away location. Slotting style controls whether and how SKUs are slotted in a facility. Replenishment frequency determines how often, in clone run real time, the current inventory position of the SKUs in the pick face of the node is evaluated and replenishment quantities determined. Order style determines if and how orders are grouped into picking batches and the particular picking process that is executed. Batch picking, number of orders, tells OC the maximum number of orders to group together. Backorder management style controls how OC manages orders that cannot be fully allocated with available inventory. Currently, the only valid option is ship partial order. Picking inventory retrieval style controls how OC allocates inventory to the order and determines which handling units will be picked or picked from. The carrier service selection gene is used by OC to consign orders, determine the desired carrier and service for an order, and route a particular consignment to a trailer door for loading. Specifically, destination state, order class, and subclass can be used in conjunction with facility and company to tell OC which carrier and service to assign to an order. Preferred trailer door aisle face tells OC at which door the carrier will pick up the load. The carrier service parameters gene is used by OC to group consignments into manifests, control load building or unitization, and schedule carrier pickups. Scheduled pickup time tells OC what time of day a carrier will pick up the load for a particular service. Carrier load build consolidation level controls the level at which load consolidation should happen, if at all. Shipping handling unit weight and height limit define the height and weight limits for a shipping handling unit if load building occurs in the network node. All work that makes inventory flow through a facility happens by executing tasks. For OC, the time to execute a task consists of a travel component and a static component. The travel component is calculated based on the actual distance and speed relating to a particular task. OC determines the horizontal and vertical distances associated with a particular task. Vertical distances include both the up and down travel. The horizontal speed used is 1.35 meters per second, and the vertical speed used is 0.18 meters per second. The static component is determined based on the standard times that you define in the standard times gene. Standard times for task types are entered at facility and company level and optionally defined at SKU family, SKU packing level, zone and location type level. OC always apply the most specific values specified for a task type. Time to prepare inventory, pick up inventory, drop inventory, and pack inventory define the standard times to prepare, pick up, drop, and pack inventory for a particular combination of facility, company, SKU family, SKU packing level, zone, and location type.